Hi everyone and welcome to this tutorial. Today we are going to dive into the world of Python package management with Anaconda, Miniconda, and how to use the Conda tool. If you have ever wondered how to effectively manage Python environments, install packages effortlessly, or decide between Anaconda and Miniconda, you have come to the right place. I will break it all down step by step to help you master all these tools, whether you are a beginner or a seasonal programmer. So grab a coffee and let's get started. Deep dive into what is Conda, Miniconda, and Anaconda, and how to choose the right tools for our data science project. This section will provide an overview of Conda, Miniconda, and Anaconda, clarifying their distinct roles in data science. These tools streamline package management and environment creation, which are essential for optimizing workflows in various data science projects. Data science tools are very essential for managing dependencies and isolated environments. They ensure reproducibility and consistency across different projects, allowing data scientists to focus on analysis rather than setup issues. What is the common confusion among users? Many users confuse the functionalities of Conda, Miniconda, and Anaconda, often leading to inappropriate choices for their data science needs. Clarifying these differences is essential to empower users in selecting the right tool according to their project requirements. This presentation in this presentation, we will cover the definitions, features, and use cases of Conda, Miniconda, and Anaconda. This structured approach aims to facilitate informed decision making when selecting the appropriate tool for data science tasks. So let's start with Anaconda. What is it? Anaconda is a comprehensive data science platform that integrates Conda and hundreds of additional packages, simplifying the data science workflow for the users. Anaconda includes over 1,500 pre-installed packages, facilitating immediate access to a wide variety of libraries and tools essential for data analysis. Anaconda provides a graphical user interface tools like Anaconda Navigator, allowing users to manage packages and environments visually, making accessible to beginners. However, while Anaconda offers an extensive feature set, it comes with a large download size, which may not be ideal for users with limited storage capabilities. Anaconda is suited for beginners and data scientists seeking a ready-to-use platform enabling quick setup and immediate access to essential tools and resources. Now, what is Miniconda? From its name, Miniconda is a minimal, lightweight version of Anaconda that includes only Conda, Python, and essential dependencies. It is designed for users who prefer a more tailored approach to managing packages and environments without excess bloat. Miniconda includes Conda and Python, providing a straightforward environment that allows users to install and manage packages efficiently and effectively. Miniconda comes with a minimal package set, allowing users to install only the necessary libraries, thereby keeping the environments lightweight and efficient. So Miniconda offers a smaller download size compared to full distributions like Anaconda, making it ideal for users with limited internet bandwidth or storage. So Miniconda is ideal for advanced users and minimalists who prefer control over their environments without unnecessary packages. It enables precise management of dependency for complex projects, making it a favored choice among scientists and developers. What is Conda? Conda is an open source package management system and environment management system that simplifies the process of installing, running, and managing software packages across various platforms. It allows users to create isolated environments for different projects, ensuring that dependencies do not interfere with one another. Conda operates flawlessly on multiple operating systems, including Windows, macOS, and Linux. This feature ensures that users can work in diverse environments without the need for extensive modifications to their workflow. Conda efficiently manages both Python and non-Python libraries, streamlining the installation and updating processes. This capability is crucial for data scientists who rely on a variety of tools and libraries for their projects. With Conda, users can create isolated environments to maintain project-specific dependencies, reducing the risk of version conflicts. This is particularly beneficial in collaborative settings where different projects may require different library version. Conda therefore is ideal for users who need precise control over their software environments, like data scientists developing complex models. It's also useful for managing diverse projects that rely on multiple versions of libraries, facilitating smooth transitions between various stages within the project. So, how we choose the right tool that is ideal for our project. Conda serves as a package manager, allowing users to manage any library, while Miniconda provides a minimal installation. Anaconda, however, is a full-fledged distribution that includes over 1,500 pre-installed packages and graphical user interface tools, making it ideal for beginners. So what to use? We use Anaconda if you are after a one-size-fits-all approach, which works out of the box for most projects. Have 3 gigabytes of space on your computer. Use Miniconda if you don't have 3 gigabytes of space on your computer and prefer a setup which has only what you need. Pros and cons. Anaconda provides a comprehensive setup with ease of use, making it perfect for beginners, but has a large download size. Conda offers extensive package management for advanced users, but lacks graphical user interface tools. Miniconda is lightweight and adaptable, but may require additional configuration for optimal use. So, conclusion about the differences between Conda and Miniconda and what to use. Selecting the right tool for data science is crucial as it influences productivity and project success. Understanding the differences and use case of Conda, Miniconda, and Anaconda empowers users to make informed choices. In a nutshell, Anaconda is a free open source distribution of Python and R designed for data science, machine learning, and scientific computing. It simplifies package management and deployment, making it easier to work with complex projects requiring numerous libraries and dependencies. On the other hand, Miniconda is the workbench of a data scientist. Every workbench starts clean with only the bare necessities. It provides only Conda and Python, giving you the flexibility to install only the packages and dependencies you need. Conda helps to organize all of these tools. Although Anaconda comes with many of them ready to go, sometimes they need changing. Conda is like the assistant who takes stock of all the tools. The same goes for Miniconda. So, at the end, what your computer includes. Your computer will include software distribution package as Anaconda or Miniconda, and you will be using Conda as a package manager to install, update, remove packages such as Matplotlib, NumPy, Pandas, Scikit-learn, TensorFlow, and so on that you're gonna need for your machine learning or neural networks or deep learning projects.